All right, so today we're diving into a brand new AI model that's making some pretty wild claims. We're talking bigger, faster, and smarter, which, makes you wonder, how is that even possible? Let's get into it and break down what Qwen 3.5 is all about.
So, the Qwen team just dropped Qwen 3.5, and they've made it open source. And look, this isn't just another small update. This is being positioned as a huge leap forward for AI, with top-of-the-line performance in things like coding, reasoning, and even understanding images and video. But here's the real kicker.
And that right there, that's the central puzzle we're going to unpack today. You see, we're told this thing is massive, and in the AI world, massive usually means powerful, sure, but also kind of slow. Yet the developers are saying, nope, it's lightning fast. So how can an AI be a heavyweight champion and a world-class sprinter at the exact same time?
To figure that out, here's the game plan. First, we'll cover what Qwen 3.5 actually is. Then, we'll get into the weeds of the efficiency breakthrough that makes it so speedy. We'll see how it stacks up against the other big names, explore its multimodal mind, watch it in action as an agent, and finally, we'll zoom out and look at what this all means for the future of autonomous systems.
Okay, so let's start with the absolute basics. Qwen 3.5 is the newest series of large language models from the Qwen team, and the specific one we're really focusing on today, the Qwen 3.5-397B, is open source. That's a big deal because it means developers all over the world can get their hands on it and start building cool stuff.
And its skill set? It's pretty incredible. It's a beast at advanced reasoning and high-performance coding. It's got what they call agent skills, which means it can actually use tools to get things done. It understands images and video, and oh yeah, it supports a wild 201 languages.
So back to that big question. How does it pull off all this power and speed? Well, the real innovation here isn't just about making it bigger. It's about a really, really clever new architecture.
First, let's talk raw power. The model has a whopping 397 billion parameters. Now, you can think of parameters as kind of like the neurons in a brain, and this is a very big brain.
But here's the crazy part. For any single thing you ask it to do, the model only actually uses about 17 billion of those parameters. So what's going on here? How does it know which 17 billion to fire up?
The secret sauce here is something called a mixture of experts architecture, or MOE for short. Just imagine the entire 397 billion parameter model is like this huge, brilliant research institute. If you walk in and ask a super specific physics question, you don't need to pull the history department into the meeting, right? The MOE architecture is like the project manager that instantly picks the perfect small team of physics experts for your specific request. And that is what makes the whole thing so incredibly efficient.
I mean, that's a great theory, right? It sounds good on paper. But does all that efficiency actually translate into real-world speed?
Well, the data says, oh yeah, it's a huge increase in speed. This chart is showing us the model's decode throughput, which is just a fancy way of saying how fast it can spit out an answer. Compared to its own predecessor, Qwen 3.5, is 8.6 times faster with a normal amount of info, and a staggering 19 times faster when it's dealing with a really big request. So yeah, that mixture of experts idea is definitely delivering a massive performance boost.
Okay, so we've established it's powerful and it's fast. But you know the real question. How does it actually stack up against the competition? Let's take a look at the benchmarks.
So the model was put through the ringer. We're talking dozens of industry-standard tests measuring everything from general knowledge and reasoning to how well it can code. And it was put head-to-head with all the other heavyweights you've heard of, like the latest versions of GPT, Claude, and Gemini.
Let's just zoom in on one example so you can see what I mean. This is IFbench, and it basically tests how well a model can follow complicated instructions. As you can see, Qwen 3.5 is outperforming the latest models from both GPT and Claude. And this isn't a one-off. This pattern holds up across a whole lot of different benchmarks. It's not just competing, it's often leading the pack.
Now, let's switch gears and talk about what might be its most exciting feature, its ability to see. Because Qwen 3.5 isn't just a text model with eyes tacked on, it was fundamentally built from day one to understand the visual world. This is what they mean by native multimodality. A lot of other models have vision capabilities that feel kind of bolted on after the fact, but with this model, the fusion of vision and language happens way earlier in its architecture. It's basically learning to see and read as one single, seamless process, and that gives it a much, much deeper understanding of what it's looking at. I mean, take a look at this scene. It's a pretty complex real-world view from inside a car. Understanding this isn't just about spotting a car or a tree. It's about understanding spatial relationships, the perspective, the flow of traffic. This is what we're talking about with spatial intelligence, and it has absolutely enormous potential for things like robotics and, you guessed it, self-driving cars.
So this deep understanding of the world is really the foundation for the next massive leap forward, turning the AI into what's called an agent. And an agent doesn't just answer your questions. It can think, it can come up with a plan, and it can use tools like a code interpreter or a web search to actually accomplish complex goals.
To really get what that means, just look at these two puzzles. On the left, we've got a maze. On the right, that classic parking lot slider puzzle. Now, these are not simple recognition tasks, right? They require a whole series of logical steps and careful planning to solve. And this is where it gets really cool. We can actually peek inside the model's brain and see its thought process. This quote right here is from the model's internal monologue while it's solving that maze. It's literally thinking to itself, okay, to find the shortest path, first, I need to turn this picture into a grid. You can see it breaking down the problem into these super logical steps, pretty much exactly how a person would tackle it. It makes this abstract concept of AI thinking feel way more real, doesn't it?
So, where is all this actually heading? What's the endgame? Well, this combination of incredible efficiency, deep multimodal understanding, and these new agent-like capabilities, it's all paving the way for what you might call truly autonomous systems.
I think this quote from the Qwen team's own paper just sums up the vision perfectly. The goal here is to move way beyond the assistants we have today that can only really do one thing at a time. The real aim is to create these persistent partners that can work on complex, long-term goals, learning and adapting along the way.
And that really brings us to a final, pretty mind-bending question. We are on the cusp of an era where our digital tools won't just follow our commands anymore, but will start to anticipate our needs and act on our behalf. So, what happens when our digital assistants become truly autonomous? The possibilities are, well, they're kind of endless and incredibly exciting.